This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered about the mind-bending world of relativity? It's like, what if time and space aren't as fixed as we think?
Exactly. It's a trip. We're used to things being, straightforward, but relativity throws a wrench in that.
And this paper, Relativity Length Lorentz Transformation, dives right into it.
Yeah, it uses a really cool example, a bus trying to fit into a garage.
A bus in a garage? Sounds simple, but relativity makes it anything but. So the basic idea is if a bus is moving really, really fast, its length changes, right?
Right. According to special relativity, the faster something moves, the shorter it gets in the direction of motion. It's called length contraction.
So a super fast bus would appear shorter to someone standing still.
Precisely. And that's where the garage comes in. If the bus is moving fast enough, it might seem short enough to fit in a garage that's normally too small.
But then, what about the person inside the bus? To them, the garage is moving, and it would seem shorter, wouldn't it?
That's the cool part. It all depends on your frame of reference. From the perspective of someone standing still, the bus shrinks. From the bus driver's perspective, the garage shrinks.
So does the bus fit or not? It seems like it could be both ways.
It's a paradox, but a perfectly valid one within the framework of relativity. It highlights how relative space and time are.
The paper mentions the Lorentz transformation. What's that all about?
That's the mathematical magic that lets us switch between different frames of reference. It's the equation that tells us exactly how much the length changes based on the speed.
So it's like a conversion factor for space and time?
Exactly. It's how we accurately calculate the length contraction and time dilation effects.
The paper also mentions a simulation, right? A JavaScript applet.
Yeah, it's a great way to visualize this. You can adjust the speed of the bus and see how its length changes. You can even switch perspectives to see it from the bus driver's point of view.
So it's interactive. You can play around with a variable.
Absolutely. It's a fantastic tool for understanding these concepts.
The authors are from National Taiwan Normal University. And it's open source, right?
Yes, it's licensed under Creative Commons so anyone can use and adapt it. That's a big plus for educational resources.
Makes it accessible to everyone. That's great. The second article mentions other resources, like a website from a Brazilian university.
Yeah, it's always good to explore different explanations and perspectives on these complex topics. The more resources, the better the understanding.
Definitely. It's all about building a solid foundation. Both articles highlight the importance of open educational resources.
Absolutely. Making these kinds of complex topics accessible is crucial for education. Open source materials help level the playing field.
And it encourages collaboration and improvement. Right? The website iwant2study.org seems to be a hub for these kinds of interactive learning resources.
It looks like a great place to find simulations and applets for various physics concepts.
Definitely worth checking out. We saw a lot of HTTP headers in the beginning of both articles. What's the significance of those?
Those are just the technical details of how the web server communicates with your browser. Things like the date, file size, and content type. Not really relevant to the physics itself.
Just the behind-the-scenes stuff, I see. So relativity, it's not just some abstract theory, right? Does it have any real-world applications?
Absolutely. GPS systems rely on incredibly precise timekeeping, and relativity is essential for their accuracy. The satellite's speed and altitude cause tiny time differences that need to be accounted for.
Wow, I never thought about that. This discussion has really opened my eyes to the fascinating world of relativity. There's so much more to explore.
Definitely. It's a field that continues to challenge and inspire scientists. There's always something new to discover.
And it's amazing how a simple thought experiment, like a bus in a garage, can lead to such profound insights. This has been a great discussion. It's amazing how much we can learn from a simple simulation and a bit of creative thinking.
It's all about finding ways to make complex ideas accessible and engaging.
That was a great discussion. Thanks for sharing your insights.